Hello dear students, in this video I'll continue with revision for term 2 examination. In this video we will see some of the important questions from t-test and inferential statistics. This inferential statistics, it is unit 5 and the allocation of marks for this unit is 5 marks. So the only possibility of dividing this 5 marks into 2 questions is we can expect one 2-mark question and one 3-mark question. So if we see the questions from t-test, it can be asked for this 3 marks. Now let us have a quick recap of one sample t-test. The first step is we have to write the null hypothesis H0 and alternate hypothesis H1. Then we have to calculate the t statistic. It is given by x bar minus mu upon s by root of n minus 1, or we can write it as x bar minus mu upon s into root of n minus 1. Now here, based on what is given in the question, x bar, mu, s and n, we have to find the value of t and we have to check whether this value of t lies in the interval minus t alpha by 2 to t alpha by 2 for n minus 1 degrees of freedom. If this value of t lies in this interval, then we accept H0. If it does not lie in this interval, then we reject H0. Accordingly, we have to write the result. And now let us start with some of the questions on t-test. A soap manufacturing company was distributing a particular brand of a soap through a large number of retail shops. Before a heavy advertisement campaign, the mean sales per week per shop was 140 dozens. After the campaign, a sample of 26 shops was taken and mean sales was found to be 147 dozens with standard deviation 16. Can you consider the advertisement effective? So here before the advertisement campaign, the mean sales was 140 dozens. After the advertisement campaign, a sample of 26 shops was taken. So n is 26. And the mean sales of these 26 shops was found to be 140 dozens. So this is x bar. And the standard deviation is 16. This is yes. And this is mu. Now we have to check whether this advertisement was effective. If this advertisement is effective, then we will have some difference in this mu and x bar. If it is not effective, then mu will be equal to x bar or mu will be equal to 140 itself. So let us define null hypothesis H0 and alternate hypothesis H1 as follows. So we have H0 is mu equal to x bar and alternate hypothesis H1 is mu not equal to x bar. So we have a two-tailed test is applied under H0. We have the test statistic t is equal to x bar minus mu upon s into root of n minus 1. Given x bar is 147, sample standard deviation is 16, sample size is 26 and mu is 140. When we substitute all these values here, we will be able to find the value of t. So t is equal to 147 minus 140 upon 16 into root of 26 minus 1. So this is 7 into root 25 is 5 upon 16. So we get t is equal to 35 by 16. It is equal to 2.18. So we get the value of t as 2.18. Here it is given t 0.05 equal to 2.06 for 25 degrees of freedom. So if we have the graph of the t distribution, here we have negative t 0.025 and this is positive t 0.025. This is the region of rejection. If this value falls here and the value of this t 0.025 is minus 2.06. This side we have minus 2.06 and here we have plus 2.06. This region is the region of rejection and this is the region of acceptance. If the calculated value of t falls in this region, then we have to reject H0. So we have to reject H0. Here if we see this 2.18, it falls in this region. This is the rejection region. So we can make the decision. Since t equal to 2.18 does not lie in the interval minus t 0.025 to t 0.025, that is minus 2.06 to 2.06 for 26 minus 1, 25 degrees of freedom. We reject H0. We reject H0, the meaning is that there is significant difference between the mean sales before the advertisement and mean sales after the advertisement. So we conclude that the advertisement was effective. Now let us see the allocation of 3 marks for this question. Writing the null and the alternate hypothesis, it carries 1 mark. Then finding the value of t, it carries 1 mark. And then making a decision and writing the result carries 1 mark. So a total of 3 marks for this question. Next question, the 9 items of a sample had the following values: 45, 47, 50, 52, 48, 47, 49, 53 and 50. The mean is 49 and the sum of squares of deviation taken from the mean is 52. Can this sample be regarded as taken from the population having 47 as mean? So here we have a sample of 9 items and the mean of these 9 items is given here. It is 49. We need to check whether this sample was taken from the population having 47 as mean. So again let us write the null hypothesis and the alternate hypothesis. Define null hypothesis H0 and alternate hypothesis H1 as follows. H0 is mu equal to 47. Here it is given the mean is 49 and sum of square of deviation taken from the mean is 52. This sentence is given along with this sample observations. So this is x bar. This is x bar and this is summation xi minus x bar the whole square. We are asked to test whether this sample was taken from the population having 47 as mean. So the population mean mu is 47. So the null hypothesis is H0 mu equal to 47 and alternate hypothesis H1 mu not equal to 47. Thus a two-tailed test is applied under H0. We have t is equal to x bar minus mu upon s into root of n minus 1. Here although the sample observations are given, they have given the mean directly, so we need not calculate it. Here x bar is equal to 49 and summation xi minus x bar the whole square, it is 52. N is 9. So summation xi minus x bar the whole square is given. We can find the sample standard deviation from this. The sample standard deviation is nothing but it is root of summation xi minus x bar the whole square upon n. So it is root of 52 by 9. It is root 52 by 3. Root 52 by 3 is approximately equal to 2.4. So this sample standard deviation we get it as 2.4. And now we can substitute in t. T is equal to 49 minus 47 upon 2.4 into root of 9 minus 1. So this is 2 by 2.4 into 9 minus 1 is root 8. Root 8 is 2 root 2. So this is 4 into 1.414 Root 2 is 1.414 upon 2.4. This when we simplify, we get 5.656 upon 2.4 or t is equal to 2.35. So we get t as 2.35. Again, if we see t 0.025 is 2.306 for 8 degrees of freedom. But 2.35, it does not lie in the interval minus 2.306 to 2.306. Since t equal to 2.35 does not lie in the interval minus t 0.025 to t 0.025, that is minus 2.306 to 2.306. For 9 minus 1 equal to 8 degrees of freedom, we reject H naught. Hence, we cannot conclude that this sample was taken from the population having 47 as mean. So if we reject H naught, it means we have to accept the alternate hypothesis. So as a result, here it is asked, can this sample be regarded as taken from the population having 47 as mean? We have to write the result based on what is given in the question. So we write, we cannot conclude that this sample was taken from population having 47 as mean. Next question, 10 students are selected at random from a college and their heights are found to be, these are the heights. In the light of these data, discuss the suggestion that the mean height of the students of the college is 110 centimeter. So we have a sample of 10 students and their heights are given. Now we have to see whether the mean height of the students of the college is 110 centimeter based on this sample. So here let us define the null hypothesis H naught and alternate hypothesis H1 as follows. So H naught is mu equal to 110 and H1 is mu not equal to 110. This is mu. Thus a two-tailed test is applied under H naught. We have t is equal to x bar minus mu upon s into root of n minus 1. Now we have to calculate x bar, s and all since only the sample observations are given. So let us draw a table like this and find x bar. If we find summation xi, when we add all these we get 1160. So x bar will be summation xi by n. Here n is 10. So it is 1160 by 10, which is 116. Formula for s we know it is root of s is equal to root of summation xi minus x bar the whole square upon n. So if we find summation xi minus x bar the whole square, then we can find the sample standard deviation. Now after finding x bar, the next step is we have to find xi minus x bar, that is xi minus 116. When we subtract 100 minus 116 is negative 16, then 104 minus 116 is minus 12, 108 minus 116 is minus 8, like that it goes on. Then the square of all these. Minus 16 whole square 256, minus 12 whole square 144, minus 8 whole square 64, minus 6 whole square 36, 2 square 4, 4 square 16, up to etc. And then we have to add all these. When we add all these, we get summation xi minus x bar the whole square and the sum is 864. So this is equal to root of 864 by 10. It is root 86.4, approximately equal to 9.3. Now we can substitute all these values in t. T is equal to x bar is 116, mu is 110, s is 9.3 into root of 10 minus 1, which is 9. So this is 6 into 3 upon 9.3. This, when we simplify, we get it as 1.93. Let me continue here. So we get the value of t as 1.93. Here we can see that at 5% level of significance, we have t 0.025 is 2.262. So if we take this t equal to 1.93, it lies in the interval minus 2.262 to plus 2.262 for 9 degrees of freedom. As a result, we accept H naught. As I already said, this is the region of rejection. So this is the region of rejection. Here we have minus 2.262 and here plus 2.262. And this is the region of acceptance. This acceptance and rejection is for H naught. Here 1.93, it lies in this interval. So we accept H naught. Hence we conclude that the mean height of the students of the college is 110 centimeter. So we can conclude that this suggestion is true. Next question. Consider the prices of shares in rupees of a company on different days in months were found to be. These are the prices of shares of a company on different days. Calculate value of t statistic from the given data and test whether the mean price of the shares in the month is 65. So we need to test whether mu equal to 65 at 5% level of significance. So let us define null hypothesis H naught and alternate hypothesis H1 as follows. This is mu. H naught is mu equal to 65 and H1 is mu not equal to 65. So we have a two-tailed test which is applied under H naught and the t statistic is given by t is equal to x bar minus mu upon s into root of n minus 1. Here again the sample observations are given. Again we have to draw a table and find the value of s. Here n is 10. If we see in this problem, x bar is summation xi by n. When we add all these, we get 675. 675 by 10 is 67.5. And yes, we have to calculate as root of summation xi minus x bar the whole square upon n. If we do like this, here we have 67.5, a decimal number. So if we subtract, it will be difficult to square all those and add all those. So what we can do is we can use assumed mean. So these are the observations which is given in the question, and let us take the assumed mean as 65. So we get d is equal to x minus 65. And now let us subtract each of the values of x minus 65. After that, let us square those values to obtain d square. So x minus 65 is d and x minus 65 the whole square is d square. Here 66 minus 65 1, 65 minus 65 0, 69 minus 65 4, 70 minus 65 5 up to etc. And the square of all these is here. So we have summation d is 25 and summation d square is 133. Now this yes, we can calculate it as root of summation d square by n minus summation d by n the whole square. This is using the assumed mean. You must have studied this in either class 10 or class 11, where we can find the standard deviation using assumed mean. So from this we can find the sample standard deviation. Yes, summation d square is 133 and summation d is 25. So from this we get S is equal to root of 133 by 10 minus 25 by 10 the whole square. So S is equal to root of 13.3 minus 2.5 the whole square, it is 6.25. So this is root of 7.05. This when we simplify we get 2.66. Now we can find T. You know what is X bar, we know what is S and N. Let us find T. T is X bar minus mu upon S into root of N minus 1. 67.5 minus 65, it is 2.5 upon 2.66 into root 9 is 3. So this is 7.5 upon 2.66. This when we simplify we get it as 2.82. So we get the value of T as 2.82. And now if we see this critical value T 0.025, it is 2.262, and the value which we got for T, it is 2.83. It is more than this 2.262, or this value 2.83, it does not lie in this interval minus 2.262 to 2.262 for 10 minus 1 equal to 9 degrees of freedom. As a result, we have to reject H naught. So T is equal to 2.83. Does not lie in this interval. Minus 2.262 to 2.262. So we reject H naught. Here we have to test whether the mean prices of the shares in the month is 65. Since here we reject H naught, we have taken H naught as mu equal to 65. But we got the decision to reject H naught. As a result, we have to accept the alternate hypothesis. Hence, we cannot conclude that the mean price of the shares in the month is 65. So it means mu is not equal to 65. So far we have seen one sample t-test where there was one population and one sample, and we have to test whether the sample was drawn from a particular population having a given mean. Next we have two independent sample t-test. In this we have two population and a sample is drawn from each population. Now we have to check whether there is any significant difference between the mean of these two populations. So in this case, the null hypothesis will be mu1 equal to mu2 and the alternate hypothesis will be mu1 not equal to mu2, where mu1 and mu2 are the population mean of the first and the second one respectively. As far as this two independent sample t-test is concerned, we have two cases. The first case is when the sample variances are assumed, when the population variances are assumed to be equal, when sigma 1 square equal to sigma 2 square. If population 1 has a mean of mu1 and a variance of sigma 1 square, and population 2 has a mean of mu2 and a variance of sigma 2 square. The first case is where the population variances are assumed to be equal. If this is the case, then the test statistic which is used to find T, it is T is equal to x1 bar minus x2 bar upon SP into root of n1 n2 upon n1 plus n2, where n1 and n2 are the sample sizes and x1 bar and x2 bar are the sample means of the two sample. Now this SP, it is called the pooled variance. Can use small s or capital S. This SP, it is calculated as root of n1 s1 square plus n2 s2 square upon n1 plus n2 minus 2, where s1 square and s2 square are the sample variances. So this is the test statistic that has to be used when the population variances are assumed to be equal. And the degrees of freedom in this case is n1 plus n2 minus 2. So this is the degrees of freedom if the population variances of the two population are assumed to be equal. Now we have another case. Case 2, when the population variances are assumed to be unequal. When the population variances are assumed to be unequal, the hypothesis remains the same. Only the test statistic T changes. Here we have to find T as x1 bar minus x2 bar upon root of s1 square by n1 plus s2 square by n2. This is how we have to find T. The actual degrees of freedom in this case, the formula is very tedious and calculation is very tedious. If we are going to use Excel or some statistical software to find the value of T, then we can use that formula for degrees of freedom. In CBSE Handbook also they have given, we can use the degrees of freedom as smaller of n1 minus 1 or n2 minus 1. So whichever is smaller, we can use that as the degrees of freedom in case the population variances are assumed to be unequal. Now how we can find whether we have to use this T statistic or this T statistic? What we have to do is we have to find the ratio of the higher sample variance to the lower sample variance. Say for example, if S2 square is more than S1 square. Now we have to divide S2 square upon S1 square. And if the value of this is more than 4, then we have to use this T statistic. We have to assume the variances are unequal and we have to use this T statistic. On the other hand, if this value is less than 4, I am again repeating, the numerator should be higher sample variance value and denominator should be lower sample variance value. If that ratio is less than 4, then we can assume the population variances are equal and we can use this T statistic. So this is just a rule of thumb which is applied and it is useful in most cases. This is how we have to go about when we have two independent sample t-test. And now moving on to the questions. Two batches of the same product are tested for their mean life. Assuming that the lives of the product follow a normal distribution with an unknown variance, test the hypothesis that the mean life is the same for both the batches given the following information. So here we have two batches, batch 1, batch 2. Sample sizes are given, mean life in hours are given, and the standard deviation is given here. As I already said, the first step is we have to see whether we have to use t-test for equal variances or for unequal variances. Here we can see that 14 is more. So in the numerator we should have 14 square upon 12 square. 14 square is 196 and 12 square is 144. This is less than 4. This is a small rule of thumb which is usually applied to check which type of t-test we can use. This is less than 4. So we can use sigma 1 square equal to sigma 2 square. That is the first. So here we have two batches with sample size 10 and 8 and the mean life is given and the standard deviation is given. Now we need to test the hypothesis that the mean life is same for both the batches. So let us define null hypothesis H0 and alternate hypothesis H1 as follows. H0 is mu1 equal to mu2, that is their population mean are same. The alternate hypothesis is mu1 not equal to mu2. Their population mean is different. Thus, a two-tailed t-test is applied under H0. We have t is equal to x1 bar minus x2 bar upon sp into root of n1 n2 upon n1 plus n2. Everything is given here. This is n1, this is n2, this is x1 bar, x2 bar, this is s1 and this is s2. Now let us find sp first and then let us find t. So sp is equal to root of n1 s1 square plus n2 s2 square upon n1 plus n2 minus 2. So this is root of 10 into 12 square plus 8 into 14 square upon 10 plus 18 minus 2. So this is root of 12 square 144 into 10 1140 plus 196 into 8 1568 upon 16. So this is root 3008 upon root 16 is 4. This 54.84 by 4 or sp is equal to 13 point root of 13.71. So this is sp. And now we have t as x1 bar is 750 minus x2 bar is 820 upon sp is 13.71 into root of n1 into n2, 10 into 8 upon 10 plus 8. This is equal to minus 70 upon 13.71 root 80 by 18 or it is 40 by 9. So it is minus 70 upon 13.71 into root 40 is root 4 which is 2 upon root 9 is 3 into root 10 is 3.162. This when we simplify we get the value of t as minus 442 by 7 upon 41.13. It is minus 10.76. So minus 10.76 is very less than minus 2.212. So this value falls in the rejection region. Hence t equal to minus 10.76 does not lie in the interval minus t 0.025 to t 0.025, that is negative 2.212 to 2.212 for 10 plus 8 minus 2 n1 plus n2 minus 2 equal to 16 degrees of freedom. We reject H0. Hence we cannot conclude that the mean life of the two batches are the same. Since we reject H0 we have to accept H1. So we cannot conclude that the mean life of these two batches are same. Next question. Country A has an average farm size of 191 acres while country B has an average farm size of 199 acres. Assume the data were obtained from two samples with standard deviations of 38 and 12 acres and sample sizes of 8 and 10 respectively. Is it possible to infer that the average sizes of farms in the two countries is different at alpha equal to 0.05? Assume the populations are normally distributed. So here we have country A having an average farm size of 191 acres. So this is x1 bar. Country B has an average farm size of 199 acres. This is x2 bar. Their standard deviation is 38. This is S1 and 12, S2. And sample sizes are 8 and 10. Now we need to check whether the average size of the farms in the two countries are different at alpha equal to 0.05. So here if we see S1 is 38 and S2 is 12. Here let us check the ratio of their variances. S1 square upon S2 square. Here 38 square is 1444 upon 12 square. 12 square is 144. This is obviously more than 4. So in this problem, we have to assume unequal variances. Sigma 1 not equal to sigma 2. And we have to take the t statistic in the second case. Now let us solve this. Define null hypothesis H0 and alternate hypothesis H1 as follows. H0 is mu1 equal to mu2 and H1 is mu1 not equal to mu2. Here we assume sigma 1 not equal to sigma 2. Sigma 1 square not equal to sigma 2 square. Thus, a two-tailed t-test is applied under H0 when the variances are unequal. We have the test statistic t given by x1 bar minus x2 bar upon root of s1 square by n1 plus s2 square by n2. So here x1 bar is 191, x2 bar is 199, s1 is 38, s2 is 12, n1 is 8 and n2 is 10. When we substitute all these, we will get the value of t. So this is 191 minus 199 upon root of 38 square by 8 plus root of plus 12 square by 10. So this is minus 8 upon root of 180.5 plus 14.4. It is minus 8 upon root of 195 approximately. It is 194.9, 195. We know 14 square is 196. So it is very close to 196. So let us write this as approximately minus 8 by 14. Or we get it as minus 0.57. Therefore, we get the value of t as minus 0.57. T is approximately equal to minus 8 by 14, which is minus 0.57. Here we need to check whether average size of the farm in the two countries is different. We are getting t equal to minus 0.57, which lies in the region of acceptance. Since t equal to minus 0.57 lies in the interval minus 2.365 to 2.365 for smaller of 8 minus 1 or 10 minus 1, which is 7 degrees of freedom. We accept H0. Since we accept H0, we cannot conclude that the average farm size is different in the two countries, or we conclude that the average farm size are equal, in other words. So this is with respect to two sample t-test when the variances are assumed to be unequal. And next we have the remaining part, which is from theory. So under this theory part, we have population and sample, sampling methods, parameter and statistic, central limit theorem, null and alternate hypothesis, confidence interval, degrees of freedom, and standard error of mean is also included. Standard error of mean. It is nothing but it is given by sigma by root n. 1 2-mark question on this was given in the sample paper. So other types of questions which can be expected are finding the difference between population and sample. Then we have the definition for sampling, and then the steps involved in sampling. Then we have different types of sampling methods. Next we have difference between representative and unrepresentative sampling, unbiased and biased sampling. And then we have difference between parameter and statistic. And next, meaning of sampling errors and how they can be rectified. What are the reasons? Next, we have statistical significance. What is the meaning of statistical significance? Then what is sampling distribution? Next, we have standard error of mean given by sigma by root n. Here we have a question. Similar question was asked in the sample paper. The sampling distribution of sample mean x bar is formed from a population with mean weight mu 80 kg, standard deviation sigma 14 kg. What is the expected value and standard deviation of x bar if sample size is 49? Now we know expectation of x bar is given by mu. So expected value of x bar is again 80 kg. Then the standard error of mean, it is given by sigma m, which is sigma by root 10. Sigma they have given 14 kg upon root n is 49. 14 by root 49 is 2. So the standard error of or the standard deviation of x bar, it is 2. Next we have central limit theorem. This is a very important theorem in statistics. So it states that the distribution of a sample leads to become a normal distribution, that is a bell-shaped curve as the sample size becomes larger, considering that all the sizes of the samples are identical whatever be the shape of the population distribution. So according to this theorem, it is better if we take sample size which is large. A sample size of 30 or more is considered to be sufficient to hold central limit theorem, and the reason for having a large sample is that as the sample size becomes large, the prediction of characteristics of population becomes more accurate. So we can say that whatever study we have conducted on the sample is a true reflection of the population. And then we have confidence interval. Meaning of confidence interval. Then null and alternate hypothesis, their meaning, degrees of freedom and level of significance. A detailed explanation on all these topics on the theory part from Inferential Statistics. I have already made a video. The link is available in the description. So these are the different types of problems that can be expected in t-test and standard error of mean. I hope this video was useful for you. If you have not subscribed to my channel, please subscribe. All the best for your exams. Thank you for watching.